lesson is on systems of inequalities. Our objective is to graph and solve systems of linear inequalities in two variables. So here's some vocabulary. A system of linear inequalities is a set of two or more linear inequalities containing two or more variables. All that means is we're going to have two inequalities and they will have two variables, x and y. So it's very similar to a system of equations where we had two equations. They both had x and y in them. And we had to solve to see where they crossed. Well, inequalities is a little bit different, and you'll see here in a minute. The solution of a system of linear inequalities consists of all the ordered pairs that satisfy the linear inequalities in the system. What that means is, for a minute, if you'll reflect back to when we had things like, if we solved an inequality and we got x is less than 5. That meant x could be anything less than 5. It could be 4, it could be 3, it could be 2, it could be 0, it could be negative 10. There were a lot of options that x could be. And we would make a number line, and we put 5, and then because it wasn't equal to, we did an open dot and shaded to the left. That represented all the numbers x could be that were less than 5. It could be all of these numbers. Okay, so more than what you would consider more than one number as an answer. On a graph, we're going to graph the line, and then we're going to shade. Because on a number line, you have numbers. But on a graph, you have ordered pairs. So we're going to shade all of the ordered pairs. Okay, so that's kind of where we're headed here in a minute. But first of all, we're going to identify if a solution is actually a solution for the system. So for example, right here, we have negative 1, negative 3. And we need to see if that is a solution to the system. That means that x and y needs to work for this and for this inequality. So the way we check that is we plug in negative 1 for x and we plug in negative 3 for y. I'm going to erase my checks because I don't know if it really works. We're going to check. So this has already been separated for you. So we're going to try the negative 1, negative 3 into the first inequality. So under your y, you're going to substitute in negative 3. Bring down your less than or equal to sign. Negative 3 times, in place of x, we're going to put the negative 1. And then we have plus 1. So we bring down negative 3. We bring down our less than or equal to sign. Negative 3 times negative 1 is a positive 3. And 3 plus 1 is 4. Then you read this inequality and you decide, is this a true statement or is it not? Negative 3 is less than or equal to 4. Is that true? Is negative 3 less than or equal to 4? Yes. Yes. Yeah. Is negative 3 less than 4? Yes, it's less than 4. Okay, so it works. That one works. So let's try the other one. Because if it doesn't work for both inequalities, then negative 1, negative 3 is not a solution to the system. It has to work for all of the inequalities. Okay? So we're going to do the same thing here. So under the y, we're going to plug in negative 3, less than 2. In place of x, we're going to put in negative 1. And then we have plus 2. Bring down the negative 3, less than. 2 times negative 1 is a negative 2. Negative 2 plus 2 is 0. Ask yourself, is this true? Negative 3 is less than 0.
No.
Yes.
Yes.
Oh, yes. Negative 3 is less than 0. Yes. Okay. I think we're all fading. We're getting tired. The day is getting closer to the end. So, because it works for both inequalities, that would mean that yes, negative 1, negative 3, that ordered pair, is a solution to the system because it works for both. Now, we didn't have to graph. We just can plug it in to check. Okay? So we're going to do a couple of these. So let's, well, first of all, it says, remember, an ordered pair must be a solution of all inequalities to be a solution for the system. That's what I just said, right? It has to work for both. In this case, both, because there's only going to be two inequalities for it to be a solution to the system. All right, so let's try this one. So we've got negative 1, 5. We're being asked, is this ordered pair, this x and y, is that a solution to the system? We have to try it into both of these. So we're going to plug in for y, we're going to plug in 5, less than negative 2 times x is negative 1, and then bring down the minus 1. 5 is less than. Negative 2 times negative 1 would be positive 2, and positive 2 minus 1 is 1. Is 5 less than 1?
No.
No. guess what? If it doesn't work for the first one, who cares if it works for the other one? It can't be a solution to the system unless it works for both of them. So we don't even need to waste our time doing the other one. We're just going to write, no, it is not a solution to the system. Okay? Are we okay so far?
Yes.
Okay? All right, let's try this one. We're being asked, is 0, 1 a solution to the system? So y is 1 less than negative 3. In place of x, we're going to plug in 0. And then we have a plus 2. So 1 is less than, what do you get on the other side? 2. Is 1 less than 2?
Yes.
Yes, so we put a check and we move on and we try the other one. Y is 1 greater than or equal to 0 minus 1. That says 1 is greater than or equal to what?
Negative 1.
Negative 1. Is that true?
Yes.
Yes, 1 is greater than negative 1. So therefore, yes, 0, 1 is a solution to the system. Okay, now we're going to move on to graphing them. So are there any questions? Oh, wait. No, we still have another one, don't we?
Yeah.
Okay, I'm sorry. Okay, let's try this one. Let's see if 0, 0 would be a solution. So we plug in 0. Zero is greater than 1.
No. No.
No, it certainly is not. So guess what? The answer is no. We're done. Right?
Yeah.
You see why you can stop there?
Yes.
Okay. Okay. All right. Now, this is very important that you pay attention here, so that you understand the meaning of the linear inequalities. I was going to see if I could use this as a pointer without, yes, there we go. Oh, no, it might move around. Okay, so that's not going to work. All right, so to show all the solutions of a system of linear inequalities, graph the solutions of each inequality. The solutions of the system are represented by the overlapping shaded regions. Okay, now I know this is all very new to you, so I just want you to pay attention. Remember when we graphed our inequalities on a number line, how sometimes we had an open circle if it didn't have the equal to bar, and sometimes we had a closed circle if it had an equal to bar, okay? Well, when we're graphing our linear inequalities, that means we've got a y and an x, okay, and it's creating a line. If we have a less than or a greater than, it's going to be a dotted line. You might want to make a little example of that. If it has a less than or equal to, or a greater than or equal to, it's going to be a solid line. So as you look at these examples, you can see one of them solid, one of them dotted. And it really just depends if it has the equal to bar on the inequality or not. Okay, now I'm going to teach you how to graph those in a minute. But for right now, let's just look at the graphs that are already created. One graph, one line has a shading and the other line is shaded, and then you're looking at where the shading has intersected, right? Where do the colors overlap? So in this first example, it says 2, 1 is in the overlapping shaded region, so it is a solution. You see the 2, 1 right here, that ordered pair 2, 1? That would be a solution to both inequalities, to the system, because it is in the overlapped region. Okay, so all of the points in this region would be solutions to the system because that's where the overlapping of colors happen. Okay, look over here. 2, 0, this ordered pair 2, 0, would not be a solution to the system. It would only be a solution to the system that we use the blue to shade. All the solutions for this system have to be in this area right here. And as we start graphing them, it will make a lot more sense. Okay, so we're just going to continue to press forward. And as you have questions, raise your hand and ask. Okay? All right, so let's go ahead and start right away. So we're first going to graph these, and we're going to graph one at a time. Use your pencil that has the eraser to graph. We will use the colors to shade. But graph with a pencil first. So looking at the first inequality, we have y is less than or equal to 3. Now remember, this is one of those types of lines that is a horizontal line, okay, because it does not have the x, which means the slope is 0. So it's horizontal. So we're going to go I'm having a hard time seeing where my this so I can see where my axis is. There's my x-axis and my y-axis. Maybe you guys can see it a little better. Okay, so I'm going to go to 3 on the y, and I'm going to draw my line here. But I have to decide, is it going to be solid or dotted? So you want to look at the sign here. What kind of a line should it be?
Solid.
Solid, very good, because it has the equal to bar. Okay, so we're going to draw a solid line. Now, don't go graphing the other line yet. We need to shade, okay? So the way that you shade is you look at this sign, and this sign says less than or equal to. So we shade less than, all the ordered pairs that would be less than, meaning all the ordered pairs that are below the line. So take a color that you have, and very nicely, not this way, do it, try and shade it nicely. Shade in everything below your line. You want to be neat because it will help you when you start having to answer questions about your graph. It's very important that you graph it correctly or you won't be able to answer the questions that go along with your graph. Excuse me. Okay, now we are going to take your pencil again and we are going to graph the other inequality. This one says y is greater than negative x plus 5. So we're going to start up at 5. 1, 2, 3, 4, 5 on the y-axis. We're going to put our dot. From there, our slope is a negative 1 over 1. So we're going to go down 1, right 1. Down 1, right 1. And we're going to do that as many times as we can to fill this up nice and neat. And we can also go up and back 1. What type of a line is this one going to be?
Dotted.
Dotted, because look at your sign here. We don't have the equal to bar, so it is going to be dotted. And I typically will just kind of put a little dash in between my dots. That kind of makes it easy for me to see that this is dotted. Okay. Now, some people have a very hard time telling when the lines have a slope other than 0 where they're going to shade. So if you look at this, you can see it's a greater than sign. So you're going to shade on the greater than side. Can you see what side that would be? Would that be
Right.
up here on the right? That would be the higher, right? The greater values. Okay? Now there is a mathematical way you can check that. And I'm going to show you one time here. And then the other times I'm going to just visually, we should be able to see it. But if you can't, this is how you would do it. So basically, we have our line here, and we would just test a point. If we think that it's up here, I'm going to test that point right there. That point would be 1, 2, 3, 4, 1, 2, 3, 4, 5. It would be 4, 5, right? My little test point would be 4, 5. My x is 4, my y is 5. So what I would do is I would test that out in that inequality. So my y is 5. My x is 4, so negative 1 times 4 would be negative 4, plus 5. So 5 greater than 1. Is 5 greater than 1?
Yes.
Yes. Since that ordered pair worked up there above the line, that means all of the ordered pairs in that section will work, which means all of this would be shaded. Everything above that line, even overlapping there, because that's the whole point.
Wait, so how's it for 5?
I just picked that point. I just picked 4, 5. I could have picked 0, 0. And if I tried 0, 0 right here, it wouldn't work. It wouldn't be a true statement. And so, since it doesn't work there, I would know that all the points under don't work. So it must be all the points above. You can pick any ordered pair you want. 0, 0 is probably the easier one because it usually cancels out a lot of numbers. I just randomly picked that. Now, if you can see, okay, that's a greater than sign right there, so I see that greater than is up here above, then you don't have to do that. You really don't need to do that. Some kids, a lot of kids can visually see it. There are some that can't see it, so they have to use a test point. Basically, you're testing a point either above or below the line. If it works, great, shade where that point is. If it doesn't, then it's on the other side of the line where the points work. It's only one or the other, right? Okay. All right, now let's answer some questions. You can easily see here where the colors have overlapped. So it says, are the following coordinate solutions? 8, 1. Let's find 8, 1, and let's see if it is a solution. 1, 2, 3, 4, 5, 6, 7, 8, and then 1 would actually be right here, right? But if this continued out, would that be a solution? Would it be in the doubled up region?
Yes.
It sure enough would be. So yes, that would be a solution. How about 6, 3?
Yes.
That's right here. That is on the line. Since it's a solid line, you can say yes. If it was a dotted line, it wouldn't be a solution. Okay? So yes. Okay, negative 1, 4. Right here. Is that a solution? Is that in the shaded, double up shaded area?
No.
No. So that one is not a solution. And 2, 6. Right here. Is that in the doubled up shaded?
No.
No. Now that's a solution to the line that we colored with the blue, but it's not a solution to the system. Remember, the solution to the system is where the two colors overlap. So that one would not be a solution to the system. Yes?
Why wouldn't it be a solution if it's a dotted line?
Because the dotted line means it can't be equal to. Dotted line means those points on the line are not solutions to the system. The equal to bar means it could equal. Meaning all the points could be included. Okay, let's do another one. All right, look at this one. What do you think we need to do before we start graphing?
Solve
We're going to have to solve for y. Exactly. Okay, so let's take the negative 3x plus 2y greater than or equal to 2, and let's solve it. What would we do first?
add 3x.
Very good. Add 3x to both sides. So 2y greater than or equal to
3x plus 2.
3x plus 2. Then what?
Divide by 2.
Divide by 2 all the way across. So you end up with y greater than or equal to, can 3 over 2 simplify?
No.
No. Don't turn it into a mixed number. Just can the two numbers reduce? They cannot. So 3 over 2 x plus 1. Okay, so now we can graph that one. Great. So where are we going to start?
1.
At positive 1, and then we're going to go
Up 3 over 2.
right 3 and right 2. Good. The opposite of going up and right?
Down left.
Down and left. Okay, once you get those, then you have to decide the type of line that you are going to use.
Solid.
Yeah, you're right. It's got the equal to bar, so it's going to be a solid line. And then the next decision you have to make is where you're going to shade. What type of a sign do we have there?
Greater than.
A greater than or equal to. So we took care of the equal to by making sure we had a solid line, but greater than. So where are we going to shade being that it's greater than?
Left.
To the
What
right.
side?
Right here. This is the greater than sign. Once the line tilts that way, the greater than, it's greater than is always above. This is above the line. Once it starts to tilt to the right, below becomes under the line over here. That's why I say some kids can't see this very easily. So greater than would be above the line. Greater than is always above the line. It's just whether or not you can see which side is above and which side is below. My suggestion here, if you have trouble seeing that, you might want to look up here, would be that maybe you test the point 0, 0 there. If I want to test 0, 0, that means if I put 0 here and 0 in for x, right, I would end up with 0 greater than or equal to, that would all cancel out, 1. Is 0 greater than or equal to 1? No. So, did this point 0, 0 work for the inequality?
No.
No. So since it didn't work, none of the points on this side will work. So it must be all of the points over on the other side that work, and that's why we shade over there. So if you can't see, just by visualizing it, you test a point. And if you always want to test 0, 0, pretty much you should do that. Now if the line goes through 0, 0, I'd pick another point. You don't want to pick a point on the line. Pick a point on one side of the line so that you could test it. If it works, great. shade where it's at. If it doesn't, shade the other side of the line. Okay? All right, let's graph the other one. It's already ready to go. So we start at positive 3, and we go up 4, right 1, or down 4, left 1. Right?
Yes.
Solid or dotted? That doesn't look right. Hold on. 1, 2, 3. So then I went 1, 2, 3, 4 over 1. 1, 2, 3, 4 back 1. 1, 2. It is. I don't know. It should be dotted. It could just be because I don't know. Okay. Now we have to decide where to shade. It's a less than sign, so we're going to shade under. Where is under? Over here. This is under. So there's only a tiny little area there where the colors overlap. Now again, if you had trouble seeing that, you could try out 0, 0. So if we put in 0 here and 0 here, we would end up with 0 less than 3. 0 is less than 3, so guess what? 0, 0 worked, which is why you shade on the side where 0, 0 is. And that's what we did. Okay, now that one didn't have any questions to go with it, but make sure you get everything shaded on that side of the line. You should see this little teeny triangle where the shading is overlapped. Okay, on we go. Next, we're going to start at 1, and we're going to go up 1 and right 1. Or down 1 and left 1. Solid or dotted?
Solid.
Solid, good. Equal to bar means solid. Less than or greater than?
Less than.
Less than sign right here. So we're going to shade under the line. Where is under the line?
The right side.
Over here on the right side. Good. Okay, let's graph the next one. Y is greater than 2. We go on the y-axis to 2, and it is what type of a line?
Dotted.
Dotted, and it's horizontal, right? Okay. Now these are easy to tell where to shade. It's greater than, so we shade above. And then you can easily see where the colors overlap. So we need to answer some questions here about our graph.
I just switched the colors.
Okay, so, are you guys with me? I don't want to go. Good, you are. Okay. So 4, 4. Go to 4, 4. 1, 2, 3, 4, and up 1, 2, 3, 4. Is that in the double shaded area?
Yes.
Right there? Yes, that right there is. So that would be a solution. What about 6, 3?
Yes.
Yes. Yes.
Right here? Yes? Good. What about negative 3, 1?
No.
That would be here. That's not a solution for either one of them, much less for both of them, right? It's not in any shading at all. Oops. Okay, 3, 3.
Yes.
That would be in the double shading. Good. Very good. Okay? You're doing very well. All right. Is this our last one? Okay. I need for us to adjust this just a little bit because there's something that I need to make sure we're good. So instead of 3x plus 6y, I want you to change that to 3x minus 6y in the problem. Okay? Now the first one, we're good to go. The first one, we're just going to go ahead and start graphing. Okay? And we start at
Negative 7.
negative 7, which means you're going to have to kind of come down here like this. And then from there, we're going to go up 1, right 1, up 1, right 1, up 1, right 1. Solid or dotted? Dotted. Good. says y is what?
Greater than.
Greater than. Where do we shade? Above. Very good. So all these ordered pairs are a solution to that inequality, except for the ones on the other side, and the points that are on that line don't work either because it's dotted. Yes?
Is that graph right?
Should be. Down at -7. 1, 2, 3, 4, 5, 6, 7. Up 1, right 1.
I have mine on the bottom.
Oh, it's so not. Thank you. Let me adjust that. My shading should still be okay. Okay, I'm glad you brought that up. Okay, so it should be there, here, it should be here. Thank you. Does that look better?
Yes, ma'am.
Okay, good. Very good. Okay, so dotted. Okay, and then your shading, you guys are good with your shading? Whoops. All right, so your shading goes there. All right, now, in order to graph this other one, we're going to need to do what?
Solve the
Solve for y. So we're first going to subtract 3x on both sides. So we bring down -6y less than or equal to what?
Negative 3x plus 12.
Okay, then what?
Divide by -6.
Switch all the way over.
Oh, you guys do
Yeah.
remember. So we divide by -6 all the way across, but then remember, when you multiply or divide by a negative number with inequalities, you have to flip the sign. So it flips over. Now -3 over -6 would more simplified be positive 1/2 x, and then what? Minus 2. 12 over 6 would be 2. Okay, so let's graph that. That was my main concern, is that you remembered when you divide by a negative, you flip the sign. So you start down at -2, and you go up 1, right 1. I mean, up 1, right 2, I'm sorry. Up 1, right 2. Or down 1, left 2. Solid or dotted?
Solid.
Okay. Now, greater than, so we're going to shade above. Well, that's not working out too well with that color. I'll do this. Whoops. Yeah, that actually, you can kind of see where it overlaps, can't you? Or no?
Yeah.
Can you see that that's both colors?
Mhm.
Okay. Hopefully yours looks a little better. It's easier when you are using paper. Okay, so all the points in that section would be solutions to the system. What about the points that are on this line right here? Would those work?
Yes.
Yes, because
Because it's solid.
it's solid. Very good. Wonderful. You guys are great.